Hello everyone. The topic that we will be discussing is on electric field intensity due to an electric dipole at any point on the equatorial line. So to proceed further, let us have an idea about rectangular components of a vector. Let us take in two dimensions. So this one is x-axis, this one is y-axis. So this is any vector A with an origin is with the starting point is from the origin. So say this angle is theta. So what is the components of A along x-axis? It is nothing but AX is A cos theta. And the components of A along Y, there is nothing but AY equal A sin theta. So now we have an idea about rectangular components of a vector. Let us first understand the meaning of the equatorial line. So what is an equatorial line? A line which is perpendicular to the axial line and passing through a point midway between the charges of the dipole is called an equatorial line. Suppose we have a plus q here and a minus q. So this constitutes a dipole. This point plus q is at A, this minus q is at B. Then the distance between plus q and minus q is 2l. A line which is perpendicular to this axial line and passing from the midway between these two charges is called an equatorial line. So it is this line. So this is the equatorial line. So now let us find the electric field intensity at any point on the axial line. So this is the point P. The electric field at a point P due to plus Q, it is in this direction. We have learned earlier that if the source charge or the charge is plus, the electric field lines of force are readily outward. So that's why it is from away from plus Q. And the electric field at P due to minus Q at B is in this direction. Why? Because if the charge or system of charge is minus Q, then the electric field is readily inward. It is toward that charge. So let us mark that the electric field at P due to plus Q at A is E1. And the electric field at P due to minus Q at B is E2. So where is the resultant field? The resultant field is in this direction. So let us mark by E. So now the question may arise, what is the components of this vector E along, say, let us mark PC, along PC, let us mark this point as C. So what is the components of E1 along PC? So the components of E1 along PC is nothing but E1 cos theta. Then, and the components of E2 along PC is also E2 cos theta. So what is this theta? This theta is the angle between this line and this line. So So this one is theta. This one also is theta. So this one is theta and this one is theta. So now the net field. The net field at P is E. It is in which direction? It is along PC. So E is E1 cos theta plus E2 cos theta. And one more thing. What is the components of E1 in the vertical direction? It is in this direction. E1 sin theta. And what is the components of E2 in the vertical direction? It is in this direction. So E2 sin theta. So that's why this term E1 sin theta and E2 sin theta, they disappear in this equation, because E1 sin theta and E2 sin theta, they are equal but opposite in direction. So that's why they can cancel each other. But this horizontal component, E1 cos theta and E2 cos theta, they are in the same direction. That's why we add up in this equation. So this is the center of dipole. From here to here it is L. From here to here it is L. Say the distance of this point P from OA is R. So what is this cos theta? Cos theta is equal L divided by AP. But what is AP? AP, if you apply a Pythagoras theorem, we can write root over L square plus R square. So similarly, BP is also root over L square plus R square. So cos theta is L divided by root over L square plus R square. So what is E1? E1, the magnitude of E1, it is 1 by 4 pi epsilon naught. So Q will take only the magnitude. So Q divided by root over L square plus R square whole square. And what is the magnitude of E2? 1 by 4 pi epsilon naught Q divided by root over L square plus R square whole square. As you can see from here that the magnitude of E1 and E2, they are equal. So therefore the net field at E, the magnitude of the net field at P is E equal twice of E1 cos theta. E1 is equal to E2. So what is E then? E is equal twice. So E1 is 1 by 4 pi epsilon naught. So Q. So E1 is 1 by 4 pi epsilon naught, then Q by root over L square plus R square being square, it become L square plus R square. Like that. And what is cos theta? Cos theta is L divided by R square plus L square plus R square. So root over we can write to the power half. We have learned in the earlier class, if we have a to the power b, a to the power c, then we can write a to the power b plus c. So L square plus R square to the power 1 we can write here. L square plus R square to the power half. So this equation can be written as E twice by 4 pi epsilon naught. So Q L divided by L square plus R square. 1 plus 1 by 2, like here A of B plus C. So here is 1 plus 1 by 2, it becomes 3 by 2. So this E is nothing but 1 by 4 pi epsilon naught. What is 2q into L or 2L into Q? It is nothing but a dipole moment P. So L square plus R square to the power 3 by 2. So this is the magnitude of the electric field at P due to a dipole, due to an electric dipole. So special case. If R square is very large in compared to L, or R is very large in compared to L, then what is L square plus R square? So L is negligible. You can write L square plus R square is approximately equal to R square. So if you put this value L square plus R square equal R square in this equation, you can write E is equal 1 by 4 pi epsilon naught P divide what is L square plus R square? So R square. Then 3 by 2. This 2 will get cancelled. So you can write E is equal 1 by 4 pi epsilon naught P divided by RQ. So this is the magnitude of electric field E at a point P due to an electric dipole if the point P is at a very large distance from the center of the dipole. So in vector form, so E vector is equal to what? Is equal to 1 by 4 pi epsilon naught. So P divided by RQ. In which direction? So P vector. If I put here P vector, remember that I have to mark with minus. Why? Why I have to mark with minus here? Because the direction of the electric field and the direction of the dipole moment, in this case, they are opposite in direction. The electric field is in this direction, but the dipole moment is from minus Q to plus Q. Electric field is in this direction, but the dipole moment is in this direction. So that's why I have to put with minus. So what we can conclude from here, that if the point P is at a very large distance from the center of the dipole, then E is inversely proportional to